Hello there guys, and welcome to a brand new video. In this video, even as we've looked at all the basics we need to know on limits, we'll now be looking at the laws of limit, the laws regarding addition, constants, and all that. This is where we are going to talk about that. So we'll first of all look at the basis of limit. Then we'll look at already solved examples so that we see how the laws are being applied in these examples. And then we now solve some practical problems on it. If this is your first time, let's have beyond numbers where we make maths very easy to learn. Now you can subscribe if you find this video helpful at the end of it, and you can also let me know at the comment section if you have any peculiar questions or topics you would want me to go over for you. Thank you for subscribing. Let's dive in. Talking of the laws of limit, first law we'll be looking at is what? The limit of a constant. The limit of a constant. Now, if you want to find the limit of any constant value at all, any constant value, so far as it has no variable, then we can say it's a constant. So if you want to find the limit of any constant value, the limit of any constant is just what? The same constant. The limit of any constant is still that constant. Let's look at some already solved examples and then see how that is applied. So if you look at these three examples over here, we want the limit of 8 as x approaches 5. The limit of 8 as x approaches 5. The 8 here is a constant and there is no x attached to it. Hence our answer is still what? 8. For this second one here, we want the limit of 12 as x approaches negative 2. 12 here is a constant. Hence, our value still remains what? 12. Then this very one here too, we want the limit of what? 0 as x approaches 0. 0 is itself a constant. Hence, we still get to the answer what? 0 without evaluating anything. Now let's look at another law regarding limits. This second one here talks of the limit of sums or differences. The limit of sum or difference. So if you have the limit of, let's say, f of x plus or minus g of x, the only thing you need to do is find the limit of f of x. Then if it is plus or minus, you put that there and then the limit of g of x. So it doesn't matter. You can separate the two functions and then find the limit of them one after the other. Let's look at some examples to see how this rule is applied. As we can see over here, in example 1, we want the limit of 2x plus 5 as x approaches 3. So 2x on its own is a term and 5 is also a term on its own. Now we can find, removing the bracket, we can find the limit of 2x only plus, because of this plus we have over here. Then the limit of what? 5 only with the same x approaching 3. The same x approaching 3 on both of them. And we know the limit of 2x. This here is a polynomial which we've done in our previous video. So the limit of this here, 2x, as x approaches 3, we know gives us what? 6. And then the limit of a constant is still what? 5. Hence our answer is going to be what? 11. So this is how it is applied. Then this second one here, we want the limit of x squared minus 3x plus 4. If you don't want to use the polynomial as we have previously done, then you can use the limit of sums and difference to find this out. So you can first write the limit of x squared, the first term, as x approaches negative 1, minus then the limit of 3x. So we have the limit of 3x here as x approaches negative 1. And then the limit of 4. Evaluating them, this is what you are going to have. So the limit of x squared when x is approaching negative 1, we have negative 1 squared, which gives us a 1. Then we have negative 1 times 3, which gives us negative 3, then plus the limit of a constant here, which is 4. Adding all this gives us 2. So this is how we apply the limit of sums and difference. Let's look at the next one. So this one here has to do with the limit of products, just like the first one. So if you have the limit of f of x multiplying what? G of x, You can find the limit of f of x only. Then now come and multiply it by the limit of g of x also only. Let's look at how we apply this law here. So over here, we have example 1, the limit of x cubed plus x squared. The limit of what? X cubed times x squared. We have to find the limit of x cubed only. Then because of this operation sign we have here, we put the same thing here. Then we have the limit of x squared. Evaluating x cubed where x equals 2, we have what? 2 cubed, and 2 cubes gives us an 8. And 2 squared also gives us a 4. Multiplying them gives us the 32. This also over here is two functions multiplying themselves. If you want the limit of them, we are going to look for the limit of 3x only, then the limit of x to the 4th power only, as x approaches 0. So you evaluate for the first function, evaluate for the second function, then you multiply their product to give you 0. Let's look at the next law. The next law here is the limit of a quotient. The limit of a quotient. So if you have a function dividing the other, so you look for the limit of the numerator and the limit of the denominator, and you evaluate. Let's see some examples we have here. So over here, as you can see, we have the limit of what we have here, which is x cubed, which is x squared plus 2x. Then we also have what? X plus 1. So looking for the limit of the numerator as x approaches 1, we evaluate that alone. Then we come and evaluate that of the denominator. You see, then we have the limit of the numerator giving us 3, the limit of the denominator giving us 2. Then we evaluate them as 3 over 2. This second one here, we have the limit of 2x squared minus x all over 3x plus 5. So we can evaluate the numerator alone, you see, and that is going to give us the limit of 2x squared minus x as our x approaches negative 2 all over the limit of what? 3x plus 5 also as our x approaches negative 2. So evaluating that for the numerator, we have a 10. Then that for the denominator, we have a negative 1. And this gives us negative 10. Now let's look at the very last law, and then we solve some practical examples. We have the limit of a constant times a function. So if you have the product of two things, so if you have the product of a constant and a function, you can just choose to bring your constant outside and evaluate the limit of the function. This here is an example. So we have the limit of 7x. So you can bring the 7 outside so that we have 7 multiplying the limit of x. And we have the limit of x as x approaches 4 as what? 4. Then we now have 7 times 4 giving us 28. So now that we are done with this laws, let's solve some 2 or 3 questions, and then we see how we can apply them. So looking at our first example here, we want the limit of 4x squared plus 2x minus 1 as x approaches 3. There are so many of the laws we can apply just in this question. So let's see how we do that. Now we want the limit. We want the limit of 4x squared plus 2x then minus 1 as our x approaches 3. Now we can use the limit law concerning sums and then difference, so that we are going to get the limit of 4x squared as x approaches 3 plus the limit of 2x as x approaches 3, then plus, or you can say minus the limit of 1 as x approaches 3. Now evaluating the limit of, you can as well apply the limit of constant here where 4 comes out, but sometimes you don't really need to apply all the laws for simplicity's sake so that you can quickly solve your question. So over here, as x approaches 3, all we are going to do is to substitute our 3. So that we have 4, then times your x, which is now what? 3. So 3 squared. That is for the value of our x. Plus, we have this as x approaches 3. So we have 2, then times our x, which in this case is what? 3. So we put our 3 there. Then we come to the last one, which is minus the limit of a constant is the constant, so 1. Evaluating this, we have 4. 3 squared gives us a 9. Then plus 2 times 6, 2 times 3 giving us a 6, then minus 1. Evaluating this, we have 4 times 9, which gives us 36. So 36 plus 6 minus 1. 36 plus 6 gives us a 42. 42 minus 1 gives us a 41. So the limit of this function we have here, applying the rules, we are getting 41. You could have as well just substituted straightforward. But then these laws help us when we are solving more complex functions. Let's take our next example. In this next example here, we want the limit of a quotient. So solving, we can look for the limit of the numerator, then the limit of the denominator. So that we are going to get the limit of x cubed minus 2x all over. So as x approaches 0, then over, or let me just bring that down here. So over the limit of x plus 1 as x approaches 0. So how do we solve this? We can choose to solve the numerator alone and then the denominator alone. Then we now come and substitute that here and then evaluate. So the limit for the numerator, the limit of x cubed minus 2x as x approaches 0. Using our substitution, direct substitution, we are going to get 0 cubed minus 2 times 0. And all this gives us a 0. So that simply means that the numerator, when evaluated, gives us a what? 0. Then we come to the denominator, which has the limit of x plus 1 as x approaches 0. So using the direct substitution, we have 0 plus 1, which is equal to 1. Hence, if you have to substitute it back into our question, we are going to get what? 0 over 1. And we know 0 over 1 is just what? 0. Because 0 over any number is still 0. So with this, we would have even been able to end at the numerator, because if we have 0 as a numerator, the rest doesn't matter. Hence, the solution to this question is what? 0. Now let's look at our very last question under this section. This is our last question, which says we want the limit of 5x squared minus 3x plus 7 as x approaches 5. And what do? We can still apply the limits of sums and difference and constants and what have you, the products, because there's a product here in order. But we should choose to solve it as simple as possible. Hence, let's just look for the limit of the product or sums and difference. So that we are going to have the limit of 5x squared as x approaches 5, then minus the limit of 3x as x also approaches what? 5, plus the limit of 7 as x approaches 5. Now substituting, we have 5 into bracket 5, which is the substitution of x. Alright, so 5, then we close our bracket, then minus 3 times x. We know our x value to be what? 5, so times 5, and then plus the limit of a constant. We know the limit of a constant gives us what? the same constant, so we have 7. Simplifying, we have 5 times 5 squared. 5 squared gives us a 25. Then minus 3 times 5, which is a 15, plus 7. Evaluating 25 times 5, we are going to get what? 125 minus 15 plus 7. So 125 minus 15 plus 7 then gives us a what? A 117. Hence, this becomes the answer for the evaluation of this limit over here. That brings us to the end of this video. We have looked at the laws of what? Limits. That is the one regarding constant, sums and difference, product, quotient, then the limit of a constant times a function. If you have any challenge or any topic you would want me to go over for you, you can always let me know at the comment section and I'll gladly do that. If you found this video helpful, subscribe and then comment, and also comment at the comment section letting me know any way I can improve on my delivery. Thank you very much and stay blessed.